and subtract fractions. And the thing about adding and subtracting fractions in pre-calculus is most of the time we cannot type them into our calculator. So I want to start here by just refreshing, how do we work with fractions when we just have numbers in them? And then we'll go ahead and put the variables and the simplifying into them in a couple of minutes. But the overall idea of fractions is when we add and subtract, we must have a common denominator. So as we look at this first expression, 2/3 plus 4/5, we need to find a common denominator. And luckily in this problem, 3 is a prime number and 5 is a prime number, so our common denominator can be determined by multiplying those two denominators together. 3 times 5 is 15. So we're going to put a 15 in both of those. But because we just changed each denominator, we're going to have to change the numerator also so that we have the same values here. And what we did to get the 15 is we multiplied 3 by 5. So we need to also multiply 2 by 5. So the 2 was already there. We're going to multiply by 5. The thing is, the process is the same over here on the 4/5. 5 times 3 is 15. So since we multiplied the 5 by 3, we also need to multiply the 4 by 3. And this is a fairly simple example, although recognizing that fractions for some people will never be simple. But once we determine the common denominator and make the numerators equivalent, we can add these together. 2 times 5 is 10 15ths. 4 times 3 is 12 15ths. And when we add these together, 10 plus 12 is 22 15ths. And I'm fine with 22 15ths. You don't have to change this to 1 and 8 15ths. But I know how to do that. But that's not my concern there. So notice we added the numerator, we left the denominator alone. We didn't do anything to the denominator once we determined the common denominator. But if we go back and look at our words up here again, to add or subtract fractions, we must have a common denominator. And it says denominators can only be changed by multiplying the overall fraction by 1. And that's really what I did. I said 3 times 5 was 15, so 2 times 5. So we multiplied by 5 in the top and a 5 in the bottom. We did the same thing over here in that second fraction with the 3. But that's from previous years of experience, I hope. But now let's look at one where we have a variable and a number in the denominator. And similar to the first problem, what we can do is we can take the x and the 8. Did I ever press record? Thank you. X and 8. And there's nothing in common between x and 8, so we can multiply them together. And that will always give you a common denominator if you multiply the denominators together. It might not always give you a least common denominator. So we're going to try to work on finding least common denominator as we go through the notes today. X times 8 is 8x. So we're going to have our common denominator of 8x. And then over here, what happens? We multiplied x times 8, so we have to multiply 7 times 8. And in this other fraction, we multiplied 8 by x, so we need to also multiply the top of our fraction, which had a 3 in it, by an x. Don't cancel anything out, because what we have is we have that fancy one, 8 divided by 8, x divided by x. There's that fancy 1, so to speak. So when we simplify this, 7 times 8 is 56 over 8x. And then we've got 3x over 8x. And now we can combine because we have common denominators. We can't do much else. We're left with 56 minus 3x divided by 8x. So now that we've seen a couple of very simple, and I use that term loosely, examples, let's try another one. And again, what we're trying to do is we're trying to find the least common denominator if we can. Again, we can always multiply 4x times 6x to find a common denominator. But if we find the least common denominator, then we'll have to do less simplifying when we finish the problem, if any. So I am going to digress probably back to something that you did in 6th grade to find the common denominator. And what your teacher might have had you do is he or she may have had you write all the factors of 4, 8, 12, 16, and so forth. And 6, 12, 18, 24, and so forth. What can we use that's in common between our 4 and our 6 multiples? I think the 12. So between 4 and 6, we can use 12 for our common denominator. 24 will work, it's just not the least common denominator. Then we have x. We have an x in both of them, so we only need to write that once. And we're going to add. But what we did is we put something into the denominator. We still have the 2x minus 5 in the numerator, but we put something into the denominator. In this case, we did 4 times 3 to get 12. So we need to put a 3 in the numerator. Over here, on the 6x, we put something into the denominator. We still have the 4x plus 2 in the numerator, but 6 times 2 is 12. So we need to put a 2 in the numerator. Now, for the next step, some of you need to write it and some of you don't need to write it. I'm going to write it, but what we have now is we do have a common denominator of 12x. So we're going to have to simplify the numerator, but I want to write it down one more time before I get there. Again, you decide whether you need to write this step or not. And I don't always write it, but I write it a lot. We're going to finish, distribute. So 3 times 2x is 6x. 3 times 5 is 15. 2 times 4x is 8x. 2 times 2 is 4. Still over our common denominator of 12x. Well, now we can finish. We have like terms. 6x plus 8x is 14x. Negative 15 plus 4 minus 11 over 12x. Just a reminder, we cannot cancel anything on this one. In order to cancel, we need to be able to factor. We can't factor anything here, so there's no canceling. Let's try another one. We've got lots of examples. Speaking of factoring, it pops up here in this second example. we really need to factor to find our common denominator. So that's where we're going to start. So we have 4. And when we factor our denominator, we have a GCF of 5. So it's going to be x minus 3. 5x divided by 5 is x. 15 divided by 5 is 3. In our other fraction, really good practice, we've got x squared minus 9. Difference between two squares. X squared is x times x. 9 is 3 times 3. Difference between two squares, different signs. Once we rewrite those fractions a little bit, that helps with the common denominator a little bit. And what we want to look at here is, do we have anything the same in both of them? And we have an x minus 3 and an x minus 3. We've got that binomial, x minus 3, in both of them. So that's going to be part of our common denominator. Well, the other two values that are going to be part of our common denominator, we have a 5 in this fraction in the denominator, but we don't have one there. Not in the denominator, so we need to have 5 as part of our common denominator. We have an x plus 3 in this denominator, but we don't have an x plus 3 in this denominator, so it needs to become part of the common denominator. And this is the least common denominator. 5 times the quantity of x minus 3 times the quantity of x plus 3. And we're going to be adding those together eventually. But now that we have the common denominator, remember, we don't add anything there. We're going to add the numerator and keep what we have in the denominator. But then the next part is we need to determine what's going to go in the numerator. What's going to go in that top of that fraction? And we ask ourselves then, what did we have originally? Well, we had the 5 originally, and we had the x minus 3. But now we also have an x plus 3 in the denominator. And since we have an x plus 3 that we just put into the denominator, we need to put an x plus 3 in the numerator also. So 5 was already there, x minus 3 was already there. We put into the denominator an x plus 3, so we have to keep that equation the same, so we need to put an x plus 3 in the numerator. We're going to do the same process over here. Right now, we have, wrong color, we have a 5 in the numerator. We had an x minus 3 that was originally there, and an x plus 3 that was originally there, but now we have another 5 that we put into the denominator. So like I said, you can do that extra step if you want. I'm going to do it on this problem. I'll do it on the next one, I believe. But what happens now is that we can add these together. Yes, I am going to write it again. Up to you whether you want to write this step again. I'm trying not to write it, but I have to write it. When we add, or subtract for that matter, we don't do anything to the denominator once it is common. So now, that's an extra step maybe for you. But to finish, we're going to combine like terms, or we're going to simplify here, and we get 4x plus 12 plus 25. And down here in our denominator, 5 times x minus 3 times x plus 3. So when we, Tracy? Because there was no x plus 3 here. It has to be everywhere. So she brings up a good point. Try to simplify the fraction, get it all added together, and then look if something can be factored or canceled out. Don't do it in the middle of the problem. Wait till the end and then see if we can do something. But what we have here is we have a like term up here in the numerator. We've got the 12 and the 25. So when we finish this problem, I believe, is 25 plus 12 is 37. And then down here we have 5 times x minus 3 times x plus 3. We have added the fraction together. One comment you're maybe noticing is I didn't multiply out the denominator. There's a reason that it's not helpful to multiply out the denominator. Coming probably in the next unit. But sometimes we need to see each individual factor in the denominator to identify some features of this function. So we don't multiply out the denominator. I won't mark it wrong if you do, but it's going to take you a lot longer. So just to remind again, when we add fractions or subtract fractions, we're going to find a common denominator. But once again, it looks like we need to factor these. So we'll start by factoring our denominators here. And x squared is x and x. And the factors of 20 that combine to be 9. Well, 4 times 5 is 20. And then negative and negative. Over here in our second fraction, we have our 2 still in our numerator, but we can factor our denominator. And x and x. And the factors of 8 that combine to be 6, 4 and 2, minus and minus. As we look at this, once again, see if you have anything in the denominator from both. So we've got x minus 4 and x minus 4. Those are both the same. That's automatically going to be part of our common denominator. But then we have nothing else the same. We've got an x minus 5 here, but we don't have it there. So it's got to be part of our common denominator. We have an x minus 2 here, but it's not there. It has to be part of our common denominator. And so I'm writing too big here because I'm going to have to squeeze this in a little bit. And now what we need to do is we need to figure out what wasn't in the denominator that's in there now. So we have an x minus 4 in our denominator, and an x minus 5 in the denominator, and now we have an x minus 2 in the denominator. So since we have that now in the denominator, we need to put it in the numerator also. Don't forget that we have an x minus 3. Same process here. X minus 4, not new. X minus 2, not new. It's the x minus 5 that's new. We need to put that into our numerator. But don't forget that we still had the 2 in there. So we've seen a couple where I've made the problem maybe longer than it is. When it's adding, it's not really that much of an issue, that little extra step that I've been putting in. But in order to add here, we're going to keep our common denominator. But we do need to FOIL our numerator over here in this fraction, and we're going to have to distribute on this fraction. So I did sort of kind of skip a step. But x times x is x squared. X times negative 2 is negative 2x. Negative 3 times x And negative 3 times negative 2 is positive 6. First, outer, inner, last. We're adding to that by distributive property. 2 times x. And 2 times negative 5 is negative 10. So when we combine some like terms, we don't have anything to combine with the x squared. But we do have negative 2x and negative 3x and positive 2x. And when we combine all those, we end up with minus 3x. We have 6 and we have negative 10. 6 minus 10 is negative 4. And we still have our common denominator of x minus 4, x minus 5, x minus 2. So probably just about now, we're running out of room. Are we done with this problem? I think that we have to do a little bit more. Go get free. You can. Go get free. So we can maybe factor that numerator, and consequently, then we might be able to cancel out one more thing. So we've got x and x. Factors of 4. 4 and 1. Negative 4 plus 1. And then we ask ourselves, do we have anything exactly the same in the top and in the bottom? We have an x minus 4. X minus 4 divided by x minus 4 is that fancy 1. And then we're left with our final sum of x plus 1 divided by x minus 5 multiplied by x minus 2. So let's subtract now. And the process is still the same. When we add fractions together, we have to have a common denominator. When we subtract fractions, we have to have a common denominator. So we take a quick look at this and we see it looks like we're probably going to have to factor the denominator. So we factor x and x. Factors of 4 that combine to be 5 are 4 and 1, and they're both added. Over here, same kind of thing. X and x. Factors of 32 that combine to be 12 are 8 and 4 and plus and plus. Once we get these factored, then look at our denominators. Do we have anything that's the same thing in both? And what we see is we have an x plus 4 that's the same thing in both. But nothing else. Because we have x plus 1 here, but we don't have it here. We have an x plus 8 here, but we don't have it there. So there's our common denominator. It's the least common denominator. And we've seen that even if we find the least common denominator, we still might have to simplify some more when we're done. When we think we're done. But then, ask yourself, what was in the original, and then what's now in the denominator? On this first fraction to the left here, we now have an x plus 8 in the denominator. Don't forget that we still need to take into account our x minus 2. Over here on our fraction to the right, we have an 8, there's the x plus 8, there's the x plus 4, so our x plus 1 is what's in there now that wasn't in there before. And I'm going to do my extra step on this one. So we have x minus 2 times x plus 8 minus 8 times x plus 1. The reason that I recommended that you stick with me for a little while longer is watch out, because we need to distribute that negative. That's where people make their mistake in these types of problems. We've already found the common denominator. It seems, at least by looks on your face, that you understand that part of it, and that's really good. But we need to be really, really careful about that minus sign that needs to be distributed. So now, I've tried to highlight it in that bluish purple there. We're going to FOIL. We get x squared plus 8x minus 2x minus 16. First, outer, inner, last. Distribute here, we get minus 8x. Negative 8 times 1 is negative 8. And that's what people tend to miss if they miss something. Denominator, not going to change. X plus 4, x plus 1, x plus 8. We can combine like terms. So when we combine like terms, we don't have anything for the x squared, but we have 8x minus 2x minus 8x, or minus 2x. Negative 16 minus 8 is negative 24. And then our common denominator of x plus 4, x plus 1, x plus 8. So we hope we're done. We keep our fingers crossed that we're done. But the question is, do you think we can factor that numerator? And I think we can factor that numerator. So after all of that, we've got x and x. Factors of 24 that combine to be 12, combine to be 2, are 4 and 6. And it's going to be negative 6 plus 4. And down here in our denominator, we still have that same denominator, x plus 4, x plus 1, x plus 8. And now we're darn close. Do we have anything exactly the same in the top and in the bottom? Got the x plus 4. So we're left with x minus 6 divided by x plus 1 times x plus 8. Lengthy problems. Again, I might not have even left you enough space on your paper. You might want to work on notebook paper there, too. As we look at number 5 here, process is still the same. The difference on this one is that there's 3 fractions instead of 2. And let's look and see if we can factor anything first. So as we look here, we've got x divided by x minus y minus x squared plus y squared. We can factor our denominator. Again, it is the difference between 2 squares. X times x is x squared. Y times y is y squared. Difference between 2 squares, different signs. plus x divided by x plus y. So we need to determine what's going to be our common denominator. And we don't have something in common in all three of them. But we do have bits and pieces that are in common. We have an x minus 5 here, x minus 5. We have an x minus y here, and an x minus y here. X minus y is going to be part of our common denominator. We have an x plus y here, and we have an x plus y there. X plus y is going to be part of our common denominator. So a little bit simpler denominator for us this time. But watch out for the minus sign. We've got the minus here. I just want to highlight it a little bit because you have to watch out for the signs. You have to be really, really careful with the signs. But then ask yourself, what did we put into the denominator that wasn't there originally? Well, we put into that denominator an x plus y. On our second fraction, we didn't put anything into the denominator, so we're going to leave the numerator alone, which might even make that problem a tiny bit more difficult. But over here on the last fraction, what we put into the denominator, we had an x plus y, so we put into it an x minus y, and there was already an x here. And now we need to simplify. And I'm going to write it again. This next step may be a step that you do not have to write. It's x times x plus y minus, that minus applies to the entire numerator. So I just put in those parentheses to remind us that that negative applies to both the x squared and the y squared. So the parentheses might help remind you that we need to distribute that negative. And then we have the x times the quantity of x minus y all over our common denominator of x minus y times x plus y. So as we work this out here a little bit, we're going to distribute. Actually, I don't want to. So now we need to make sure to distribute this negative to both of these. But as we simplify, x times x is x squared. X times y is xy. This is minus x squared, which people don't miss, but it's also minus y squared. And then distributing here, we get plus x squared. If you combine like terms, in our numerator here, we've got a negative x squared and a positive x squared. So we still have one of the x squareds left. We've got a positive xy and a negative xy. They cancel out. But then we have minus y squared. And in our denominator, we have x minus y times x plus y. Can we factor any more to simplify? And our numerator is the difference between two squares. X times x. Y times y. Difference between two squares, different signs. And I said it, didn't write it, different signs there. Do we have anything exactly the same on the top and then on the bottom? The x minus y's are the same. The x plus y's are the same. What's our answer? It's 1. Problem number 6. It is lengthy. We need to add the numerator together. We need to add the denominator together. And then we're going to have to divide. So as we look at the numerator here, take a closer look at the numerator here, we see that we need to factor at least one denominator. And x squared minus 9 is the difference between two squares, which is x times x, and 9 is 3 times 3. And difference between two squares, different signs. And then we're going to add to that the 2 divided by x minus 3. So once again, what we notice is, do we have anything that's the same in both of those denominators? And we do. We have an x minus 3. But then we also have this x plus 3. So there's our common denominator. For the very top of this fraction. And over here in our first fraction, we didn't put anything new into our denominator. But on this fraction to the right, we did put in an x plus 3. We had an x minus 3 there, but now we have x plus 3 as well. So we have to put that fancy 1 in there. Don't cancel anything out. If we simplify, what we end up with is 4 plus distributing 2x plus 6. And that's going to be all divided by x minus 3 times x plus 3. If we combine like terms, we get 10 plus 2x divided by x minus 3 times x plus 3. We do notice that we could factor out a GCF. And we've got 2 as our GCF, and then we've got 5 plus x, and then x minus 3, and x plus 3. But remember, all that we've done so far is we've looked at the top of the fraction. Well, now we have the bottom of the fraction, and we need to find the common denominator there. But luckily, all that we can do is we can multiply those two together. So on your paper, you can maybe write to the right. I'm going to have to write down here, and I'll switch colors. So we have 1 divided by x plus 3 plus 1 divided by x minus 3. And when we multiply these two together, we'll have common denominator. X plus 3 times x minus 3. That's the only thing we can do for the common denominator. X plus 3, x minus 3. And we're going to be adding these two fractions together, but in order to add these two fractions together, we've got the common denominator. We need to make sure that we've got our numerator in sync here. And we put into our first fraction in x minus 3. So we've got to put in there, in our numerator, an x minus 3. Over here on our second fraction, we put into our denominator an x plus 3. So we need to also put the x plus 3 in the numerator. And luckily, these are both multiplied by 1. So when we simplify this, we have x minus 3 plus x plus 3 divided by x plus 3 times x minus 3. And what happens then is when we combine like terms, the 3's cancel out, and we have 2x divided by x plus 3 times x minus 3. Now let's put it all together. Because what we found at first is we've got our 2 times our quantity of 5 plus x divided by x minus 3 times x plus 3. But instead of writing it in this complex form, let's put our division symbol in there. And now what we're going to divide by is what we just found, which is the 2x divided by x plus 3 times x minus 3. Let me remind you, when dividing, don't ask why, flip the second one and multiply. So we've got 2 times 5 plus x divided by x minus 3 times x plus 3. And then we're going to flip the second one. So x plus 3 times x minus 3 and multiply. And when we multiply, we can multiply the tops together and the bottoms together, and then we can cancel. Although before we even get there, we can look and see, do we have anything exactly the same in the top and the bottom? And what we see is we've got in x minus 3. X minus 3 divided by x minus 3 is 1. X plus 3, and then x plus 3. We even have a 2 here and a 2 there, which allows us to finish our problem here. 5 plus x divided by x. Lastly, don't cancel out the x's. We need to be able to factor to cancel out the x's. And we've done all our factoring and we've done all our canceling already. So we are finished with this problem.